This is one of the first pictures released by the James Webb Space Telescope. We have had a couple of earlier ones. I think there was a calibration image, maybe another one. But this is one of our first, good looking images, and there's a lot going on in here. So I just wanted to spend a little bit of time to talk about it and show you what's up. So the first thing I want to mention is the diffraction lines. I think those are pretty cool. These diffraction lines, I had this theory that since James Webb has hexagonal mirrors, that's kind of what we're seeing is these hexagon shaped patterns. We see these little 60-degree angles here, and then when you stack enough of these little stars on top of each other, you start to get this hexagonal, almost cubic type of look. And what's also kind of cool is that inside of here, one of the first things that they talk about are the diffraction spikes. So one of the things that's kind of cool is if you look up Hubble diffraction spike, you'll notice it's not hexagonal. It is, it's just this kind of X shape, whereas a James Webb is this X shape with the line down the center, or what I perceive as 60-degree angles. So I think that's kind of cool. Hubble has a circular mirror, and I'm not sure about how the aperture looks and stuff, but I know its mirror is circular, so I just think that's kind of interesting that it appears as though these diffractions are caused by the mirror. So another thing I wanted to talk about real quick was, well, just a couple of the things that the arrows are pointing at. So let's kind of bring this up full screen and let's see what's really going on here. So we talked about these little lens flares or diffraction lines, I'll call them for now. And a couple of things I want to point out. So one of the other things that you see right away are these really curvy, kind of smeared pieces. And that is due to an effect called gravitational lensing. In gravitational lensing, there's a really good picture that I think pretty much does the job. Distant galaxy, and then there's some big cluster, and then here we are. So what we're seeing is, some of these galaxies that are smeared in the real world, they might actually be directly behind this galaxy right here. But since the light is shooting off in all directions, and there is a galaxy here, it gets curved, whoosh, and that's why we see this kind of spherical or circular shape here. A couple of the things that I think are pretty cool. Let's take a look back down here. So we talked about diffraction, we talked about gravitational lensing. Let's take a little bit of a look at the color here. So there's a lot of color. There's a lot of darkness, there's a lot of red, there's some white, and then there's some blue and red artifacts from the diffraction. So I'm not too concerned with the artifacts from the diffraction, but I do just want to talk a little bit about the galaxy colors. In case you're not familiar, galaxies that are really far away are moving away from us really fast. The faster they are, or the further they are away, the faster they move away from us. So I think it's kind of interesting when you look at these pictures, you can see these, galaxies, this galaxy cluster, which is causing this lensing effect, is kind of this whitish warm color, whereas the galaxies being lensed are a much darker shade. So I think that's probably a result of them being not only farther away, but then also potentially a little bit of morphing of the wavelength during the gravitational lensing. So it potentially changes a little bit of the color just by virtue of lensing happening. I don't know about that. That's just a theory, though. And then what's really cool, in my opinion, is you got some of these spots that are really red. I'll remove this just so you can get a better context. Or as a matter of fact, I'll even just go up here. So let's take a look again. So like up here, there's a couple really red ones. And then where was that other one? Yeah, right here. Look at how red that is compared to everything else around it. I mean, that is one of the reddest things on here. So we know that's probably pretty old. I mean, if that's a galaxy, then it's really old. That's got to be an old galaxy. If it is some sort of gravitationally lensed star, then I guess it could be a red dwarf or something, but I don't really see any reason that that's lensed by anything, at least to a significant enough degree. But again, that lensing thing was just a theory. So I think that's really interesting. Now, a couple of other things that I think are interesting. I think, yeah, I think there might be supernovas in this picture. I could be wrong, but if you're looking at this many galaxies, it's not totally unreasonable to think there's a supernova. Also, look at this, another red one. Sorry, I just found that. That's very red. That could be a red dwarf, though, because that's just sitting there. Looks more spherical. But anyway, back to our supernova flash. Check this out. I think there's a chance that this is a supernova. I could be wrong, but just as a reminder, a supernova is an exploding star. To put it simply, anyway, I'm a citizen scientist, so don't take my word for anything that I say, but double check it. You know, I think these are good theories, and you know, I try to get my information from NASA and stuff. So anyway, a couple other things. I think that we see a quasar, quasi-stellar radio source. So let's take a look real quick. Quasar is basically just this big jet that comes out of a galaxy. So I think there's a chance that there's a quasar shooting up from this galaxy. I also would understand if that's pretty ridiculous, because that would be a really powerful quasar. But again, it's just kind of it almost looks like a tornado plume that comes from the bottom and top of some galaxies. And let's get a better grip on the, whoopsies, yeah. So it's a type of active galactic nucleus, a quasar. And it's a massive, extremely remote celestial object emitting exceptionally large amounts of energy and typically having a star-like image in a telescope. It has been suggested that quasars contain massive black holes, or maybe supermassive, and may represent a stage in the evolution of some galaxies. PBS Spacetime also has a really good video on this called Why Quasars Are Awesome. I'll highlight that right there. Give it a little bold. So, oh, and they also could fit under the classification of a radio galaxy, which is a quasar with super powerful jets. So if that is indeed what this is, that's pretty cool. We get to see a quasar. Okay, let's take a look at this note down here. Supernova? Cloud mass? I think that's a galaxy. I had a lower res image of it, but I thought that might have been something else. So let's disregard this little piece right there. Globular cluster. I mainly just like the word globular. So anytime there's a cluster, even if it's not technically a globular cluster, I'm putting the word globular in there because I like it. Globular cluster. You know, just a little cluster of galaxies here in the middle. That's doing that lensing. So really extraordinary, super exciting. And there's just so much to look through. Again, there's this super red dot right there. There's something almost pinching into the yellow greens right here. I wonder if that's just an artifact. There's lensing just all over the place. Gravitational lensing is just happening like crazy in this picture. But you know, if you spend a little bit of time, you really can start to discover little details that, you know, get you excited. Like, again, there might be a supernova happening right there. And if you look at other stars, you start to think, oh, maybe there's a supernova happening in this one too. You know, it would be hard to tell because it might be, you know, just an object between us and that system. I'm guessing if there was a supernova on a really distant galaxy, that it would still be decently redshifted though. So this is not very redshifted, I guess, so it might not be a supernova. Let's see if we've got any more notes to look at. Okay, it doesn't. Oh yeah, there's this little thing right here. What's this doing down there? It's really silly. I just thought that this kind of looked like a duck or something. See how that kind of fits on there? Yeah, very silly, but that's just something from before. So yeah, just a little look there. A couple other things. Let's just take a quick gander at uh, this little walkthrough here. And again, this can be accessed through webbtelescope.org. I'll have a link in the description. Yeah, great comparison. Definitely love to see the Hubble Ultra Deep Field anytime. Yeah, we get a little, well, not a little, quite an increase in sharpness with JWST and detail. Things are, yeah, things are just brought up a little bigger. And as we do look back, there'll be less stuff to look through because infrared can kind of cut through some gas, which is nice. I think I'm going to end the video here. Thanks for coming in today and to this video and hanging out. And let's look forward to tomorrow, as of the time of the recording of this video anyway, which will be July 12th, where NASA is going to unveil the rest, well, some extra new photos. So 10:30 a.m. EDT, July 12th. We'll be seeing you there. All right, everyone, take care.